Let's go. Good afternoon, everyone. And so welcome to this workshop. This workshop is on sustainability of 6G mobile networks. So it's a completely new topic in this conference, which is sustainable places. So if you attended some of the other sessions, you may have seen it's around the built environment, smart cities, and this morning we had a session around smart buildings, and that's where I guess we see quite some connection potentially with mobile networks as well. And voilà, and so we managed to have a group of 8 projects, and voilà, the common point is that all of them, they have in mind sustainability from a specific angle, and so I guess that today we will learn a bit more about the different approaches. So I will leave the floor to Sébastien Faye, who is coordinator of 6G Twin, and he will introduce the workshop.
This is the mic. Good. Okay, well, we are not a lot, but I hope we will be very productive then, very stimulating discussions. Thank you all for being there. Thank you all of you, all the representatives from these projects for having accepted the invitation. Whatever happens today, in any case, the discussions will be quite interesting, I'm sure. And this is indeed a nice way to anticipate, you know, what could happen next year, the next SNSG work program. Maybe there we could identify some synergies. So I'm happy today to be there and to kick off this. So indeed, on my side, my name is Sébastien Faye. I come from LEAST, which is also co-organizer of this event with R2M. So I know maybe you understand the reason why behind this workshop. And I just prepared a few slides, but very quick slides, because I guess this is not the topic of this conference, 6G, connectivity, 5G, and so on. Just to explain a bit what is 6G, what we are talking about here. So maybe just to identify the different people in the room to start. So who is from the projects? Okay, so the three of you do not know probably what is 6G, right? And you too. Okay, so I will try to explain as much as I can why 6G and give you a bit of context there before we switch to the project presentations. Well, a few days ago I collected these 2 plots. So they come from Ericsson and Nokia, 2 of the most popular network manufacturers, let's say, at least in Europe. And so there what you can see is the amount let's say this is the global mobile network data traffic generated by our devices, right? So there you can see an amount of bytes, I guess, exchanged on a monthly basis. And these plots are based on, both real and synthetic data. So the conclusion, and I guess Nokia and Ericsson quite agree on this, I mean, if we compare what happened in 2020 and what will likely happen in 2030, this amount of data traffic will go times 10. So this is very huge. This means that the amount of data generated by our devices will increase, but in a really crazy way, right? So we need to adapt our infrastructures. We need to adapt the network technologies that are supporting that. It's very much important. So of course, this does not explain why do we need 6G, but this is one of the reasons behind. The capacity of today's networks could simply not be enough, you know, for the future. And then, of course, if you complexify the networks, then you can introduce, I mean, this means that you also need to integrate a bit more of intelligence, new technologies, and this is basically what we are talking about when it comes to 6G. So there you see an overview of all the generations. So, well, I guess this is something that is quite typical in this industry, to aggregate, you know, a set of technologies and to name them, 1G, 2G, 3G, 4G, and so on. So, I mean, just to make it simple, it's such an effort, I think, worldwide, you know, to synchronize the mobile network operators, the industry, the standardization bodies, the guys that are researching, developing the technologies, that at the end of the day, we end up with generations that are commercialized more or less every 10 years. So today we have 5G, we still have the other generations, of course, and the target then would be to end up with 6G in around 2030. I don't have the exact timeline in mind, but we still need to go through some steps. So today, the idea is really to focus on that, on connectivity, on these future networks, these future trends, and to try to, study how much this could be sustainable. Of course, when we have more complex infrastructures, when we multiply the number of nodes and antennas and so on, then we could raise some questions related to energy efficiency, sustainability, and so on. So today, again, thank you for that. We have a selection of 8 projects, well, 7 actually, that will all present their views on this topic, and that will give, well, an introduction of what they are doing exactly before then going through a panel discussion that will be orchestrated by Regis. Thank you also for that. So, well, first presentation by Monique, 6G Society, 6G for Society, sorry. So I'm not sure, I guess you can sit or take the mic.
So if you don't mind, I prefer to stand, because after lunch I feel I might. So, and I also think, well, thanks a lot. While I just puts up the slides, I will introduce myself. My name is Monique Calisti.
Maybe grab the microphone in case there are people online.
Sure. Is it working? It's not working. Hello? Hello, hello? Oui. Okay. I don't know where's the camera for the people that are there, probably. Good afternoon. My name is Monique Calisti. I'm based in Switzerland. My company, Martel Innovate, is coordinating the project. Actually, Martel is also a Dutch subsidiary, and this project is coordinated from the Netherlands. We have also created recently a spin-off that is focusing on digital sustainability, that is called Digital for Planet, that is also involved in this project. Our idea is, I can do that if you want. Okay. Okay. So our idea today is to discuss with you a little bit what we're doing in the 6G for Society. Several of you are already involved in SNSJU projects and know already the context. What this small project is, a coordination and support action running for 2 years, is trying to do is to gather input, knowledge, information from the ongoing projects, but also from relevant communities and initiatives across the member states in order to align on the design of technologies, of 6G technologies and solutions that by design are sustainable. Sustainable at which level? Environmental, societal, and economic. We have several other partners, as you can see here, and it's a very multidisciplinary kind of approach we're having. We have sociologists, we have ethics specialists, and as you can see in the next slide, what we're trying to do is, first of all, to understand better what are the key concerns to be taken into account when designing 6G as a new technology that doesn't want to suffer from what 5G has been going through. As you know, there were a lot of there was a lot of acceptance problems, a lot of criticisms for the unknown effects, negative impacts that 5G would have on health, on the society, on the environments. And with 6G, we want to have the opportunity to do it right from the first point. The idea is to, first of all, ensure that value-based and ethical-driven and sustainable methodologies and knowledge are embedded, integrated also at the technical development level. As you know, digital for the planet is only one side of the coin. The other coin is that the digital is also having a huge negative impact on the planet. So we must ensure that we design technologies that help protect the environment, but also restore the environment. Now, what does it take to get there? It takes to talk to different actors, to different stakeholders. Not only technologies can address this problem. I think this conference, it's my first time at Sustainable Places, is a great example of how different disciplines, different kind of players come together to address very challenging problems. And I think to have this workshop as a first, it's of course showing that there is little understanding maybe on why it's important to talk about networks. We need to talk about the networks because they are the digital backbone of our society. So there's no chance to build sustainable places, buildings, environments without the networks, the skeleton, to be also sustainable by design. Finally, there's a lot, of course, of resistance, but there's also a lot of work to be done at policy and regulatory level. It started in several projects, also from SNSJU, and also in other initiatives. And what we're trying with this CSA is to connect the dots among these initiatives. It's a 2-year project, so we have to be pragmatic in what we expect to achieve in terms of outcomes and impact within this period. So the first, one of the first key aspects is to make sure that we mobilize the SNS stakeholders, but also that we help them connect to stakeholders in other contexts, research, innovation, policy making, in order to have this holistic approach to the way in which we build technologies. We are focusing our work on creating a technology acceptance model. We're working with citizens, we're working with sociologists, ethics experts, in order to create a model that can help driving design and implementation efforts. As you might know, we have within the context of SNSJU projects several key value indicators. These key value indicators are used with a diverse understanding. So what we're trying to do is to converge towards a common set of those indicators so that we can all align on common efforts. We are also working on key sustainability indicators to be explicitly mentioned in the work programs, to be explicitly mentioned in the call text, so that public investment, but possibly also private investments in the future, will take that into account from the beginning. And last but not least, we hope to create also a positive effect towards standardization and regulation. So I think, yeah, that's it. One of the things is that we're running webinars. We will start a series of webinars, some workshops online in collaboration also with EXA-X2 and other projects. In this slide, you see a few of them. A few more will be put on our website, on the 6G4society.eu portal. So if you follow us, you will learn more. And I think that's pretty much it. So I will leave the floor to the next speaker. Thank you very much.
Thank you very much, Monique. And I think it was perfect to have you to kick off this session, to put this into the context of the overall Sustainable Places event. So let's continue. And again, we'll keep the questions for the end. Huh? So the next project is going to be BeGREEN.
Thank you. My name is Chiara Lombardo. I'm the technical coordinator of the BeGREEN project. And as a segue from the previous presentation, Monique correctly pointed out how we had the problem with 5G, with the acceptance of the technology. Well, I would like to say that it was not the only problem that we had with 5G. Another one that is very relevant and particularly dear to my heart is the one about the sustainability of the technology. Since 5G was the first generation of mobile networks that was fully, at least as an intention, virtual, everybody was thinking, well, it's virtual, it's not going to consume energy. Little did they know that virtual objects run on servers, and servers consume a lot of energy unless you do something to regulate their consumption, to have them be more efficient. So we basically, I have no problem in saying that we lost a generation. So we're trying to do something, not to do the same, not to repeat the same mistakes with 6G. So this is the spirit under which our project was financed. Can you go to the next one, please? So BeGREEN focuses on the core of the network, very broadly said. The idea is to have the promotion of energy efficiency, starting from the core, moving to the other portions of the network, but especially involving the other stakeholders. So not only those who actually own the physical devices that consume energy, but also have the stakeholders that deploy their applications, their network functions on top of these physical devices, have an idea of how much they're consuming, and to give them the tools to do something to improve the actual carbon footprint ascribable to their actions. So you can be a vertical application provider. You pay a flat bill, so to say, for the machines that host your application. But unless you are motivated, somehow incentivized to do your deployment and to follow the life cycle of your application in a virtuous fashion, you won't do it. So what do we want to do? We want to start from the involvement of all the stakeholders participating in the 6G value chain. We start from 5G technologies and we provide an evolution. We're not purely a 6G project. And so we start from the 5G SBA. We provide evolutions that will allow to enable all the stakeholders reducing their footprint by involving them in a win-win green economy business. So there are several aspects, of course, in our project, but the one I would like to focus on today is the one about the involvement of the stakeholders in a green economy business, in this case. Next one. So one of the most innovative concepts that we have introduced in BeGREEN is what we call energy-aware backpressure. That is, on the one hand, a set of cross-domain observability mechanisms and analytics that allow to determine how much consumption is ascribable to something that is virtual. So you know that a lot of different applications, network functions, or just components of a bigger application or network function can run at the same time on the same piece of hardware. So it's non-trivial to understand which amount of consumption is ascribable to a specific application. This is the aim of our project. At the same time, we want to combine this observability part, so this understanding of the consumption ascribable to something that is virtual. We want to combine it with a business model that incentivizes you to have a more sustainable approach, that gives you the tools to understand how much of a carbon footprint you're responsible for and do something to prevent it, or at least to improve your sustainability. We designed to include something called the decarbonization level agreement, which is similar to the service level agreement that we are all aware of, but related to a common goal of decarbonizing the system for all the stakeholders. Next one. Which comes with a question, of course. We know that European projects has a lifetime. They come, they go, and you're happy with the outcome, but it's not very common to actually see a result in everyday life. This is not an ambition of a 3-year project, but that's something that I think is worth discussing today, that we're all here in the same room with quite common ambitions for 6G technologies. So the challenge is something that I don't have an answer for, but I would like to debate with you, is that once we have these business models, everything is in place, is nice and determined. Do we believe that all the stakeholders would really embrace them and decide to have an enforcement of those DLAs? Or would it be, do we also need to have something above the market? So some, I call them regulation bodies here for lack of a better term. So something above the market that can in some form pressure, so to say, to have this kind of business models enforced on a larger scale. That's the question I want to close my presentation with. Thank you for your attention.
Thank you very much indeed. Let's giving already some material for the discussion, which will begin after the presentation. So I will now invite the BeGREEN project, and that's going to be Simon from Accelera.
Hi, good afternoon, everyone, and welcome, and thanks for letting me give a few words about BeGREEN. So part of the idea of BeGREEN, if you want to go to the next. So we need to understand what's energy saving. So BeGREEN focuses on energy saving. So one aspect of sustainability of network going through. Now, if you look at what happens in current networks, mobile impact consume considerable amounts of electricity. Yeah? So it's ICT, sort of typically up to 9% of all global consumption, and mobile networks are increasingly driving more and more of that. And that's an issue in the fact of sustainability, greenhouse emissions, but there's also a big issue of economic viability. Operators have a big expense, a yearly OPEX expense of paying for all this electricity. So there's an economic value as well as sustainability, environmental value on trying to save energy on these networks. Because as you see, the power is typically like 20 to 40% of operational costs of running these networks. So anything you can do as mobile network operators typically run on lower and lower margins because of the competition and commoditization of networks. There's a strong focus on saving energy. So 5G has been focusing on saving energy in some aspects compared to 3G and 4G, but because there are so many more users, because there are so many more frequencies and higher ranges of frequencies, all these things require additional equipment, additional power consumption. And so the goals, if nothing is done about it, is that 5G will require even more and more energy as throughput goes through. And so of course to fulfill the sustainability goals of net zero and carbon reduction and things, it's vital that we do something about it in our domain of networks. And one thing that is changing in 5G, I mean, we all have smartphones and we all use public networks, but increasingly 5G, and as we go towards 6G, will start to introduce private networks, so networks for dedicated purposes. And that is something that I'll just touch on if you can go to the next phase. So what is happening in the mobile thing is that more and more vertical industries are starting to adopt networks for their own private uses. And this is certainly a link with the sustainable places, because a lot of the construction industries are talking about drones and robots and having reliable, secure connectivity and AR glasses and things is part of the transition in the construction industry is something that is very important. Manufacturing is one of the early adopters. A lot of the big manufacturing plants are already installing their own private networks, and more of these will go to other types of verticals as well. Offshore is another one where there's wind farms are being connected, and there's a lot of interest in things like healthcare and education and retail and things. So as that progresses in the future, enabled by 5G and then later 6G, the demands for energy will explode due to all the extra devices and all the extra networks. So that was one of the motivations for BeGREEN as a project. So trying to save energy is not entirely new. So 3GPP, which is the organization that defines the standards of 3G and 4G and 5G, have already been looking at it for a long time. Initially, the focus was on trying to extend the battery life of your smartphones by saving energy in your battery. But increasingly, it's moving to also trying to save energy on the network side. And that's an area that we've been pushing for get greater energy efficiency, because you heard from 6G that focus on the core network, but one of the key energy users is what is called the RAN, the radio access network. So that's typically these big towers for public networks with the antennas and all the power amplifiers driving these signals to connect your phones. So a big amount of the energy consumption is in the RAN element. And the project BeGREEN focuses specifically on the radio access network and what you can do to make that energy efficient. So it's a very technical project focusing on specific aspects of energy saving. And so what we do, as I mentioned, so the RAN is the area we focus on, and there's no single solution. You have to try and save energy in the power amplifiers, in the equipment you use, in all sorts of things, but we're continually innovating to trying to improve energy efficiency and understanding where we can really make a significant difference to the energy that's consumed. And one aspect that we're also doing by adopting what is called Open RAN, which is a new way of designing networks, also introduces intelligence, because one of the changes as we go to 6G is that there will be native AI/ML in all the different parts of the network, optimizing and automating the network, trying to provide, and one of the key use cases for this intelligence is to save energy. So that's an area that we're looking at. So it's a project that is part of the smart networks and services that we've heard about. We've been going for sort of 19, 20 months, and we finish next summer. So there's the website, you can look further. It's not really the forum to go into any technical details, so I'll skip all the technical aspects. Okay.
Thank you very much indeed, Simon. And the next project is going to be Centric, presented by Francesco.
Yeah. So, thank you very much for still being here. Thank you very much for the invitation, and thank you very much to the previous speaker for mentioning AI native things. So this is our bread and butter. So Centric is about native AI interfaces. So I don't need to convince you that 6G networks are hard to manage, to design, to operate. So the Centric idea is to face all these challenges through artificial intelligence, and that is one side. The other side where we try to innovate is what we use the artificial intelligence for. So the inputs are on these columns. No? So we give the classic things, network topology, radio technology, locations about the user's requirement, about the services, capacity and capability of the infrastructure. That is the classical ones. Furthermore, we have human-centric metrics. So metrics that make the network more sustainable for a wide variety of meanings of the term sustainable. So we have energy, we have CO2, which is not necessarily the same, as you know, because we are going through virtualized things. We can decide where to run the virtual machines that Chiara was mentioning. So we can, for example, place them where they consume the same, but they pollute less. Furthermore, we have one specific human-centric metric, which is electromagnetic frequency exposure, which is tied also to the societal acceptance issue that was mentioned previously. So we feed all these things into our AI models. At the very end, we get decisions. But the interesting thing is we are not interested in performance or in sheer performance anymore. So we know that we have a KPI target. We must guarantee a certain performance. But besides that, we should look at the human-centric metrics. So provided that I give my services and my users the performance they want, let's, for example, minimize energy cost, or minimize or maximize fairness in which I treat my users. So we are swapping, if you like, constraints and objective. And if we can move to the next slides, so this is slightly more technical, but I think it ties also with the sustainability and human-centric thing. So because we are pursuing human-centric metrics, because we have a KPI target and that's it. So it's not our goal necessarily to get the best possible performance. It also means that the infamous artificial intelligence machine learning can be approached in a slightly different way. So a 6G network looks like this. So you have the different pieces. You have the models, plural. So for the same task, there are multiple ML models that you could select. You have the data sources, and they are not the same. So they have a different quality. They may be more or less problematic from the privacy viewpoint. For example, you have the physical nodes to run the virtual machines, and then you can mix and match. You can look at different trade-offs between your KPI target and your human-centric metrics. This level of flexibility is something new that comes with, I mean, should have started with 5G. We are not seeing that, so we are expecting that for 6G, and we can exploit this flexibility to improve the sustainability and the human-centricness and acceptability of the next generation of networks. Thank you.
Thank you very much indeed, Francesco. That's getting a bit more technical indeed, but so far I'm amazed by the complementarity of the various presentations. So that was maybe not on purpose, but so far it's a good fit. Yeah, of course. Let's move to the next presentation. That's going to be this project COALESCE.
I know, my parents were not nice to me. They gave me such a difficult thing. Right, so I'm Indrakshi. I belong to the Walton Institute of Information and Communication System Sciences. We are the largest ICT research institute in Ireland, and we have been operating for the past 25 years and we have been working on networks since the FP7 framework and even before that. Now, COALESCE, the project I'm going to talk about today, is a little bit different from the projects that has been presented so far. Because it's a combination of Marie Curie Staff Exchange Network and Doctoral Network. So it's a little bit larger project. It will be running for 4 years, and we are just 6 months into the project. I'm still hiring PhD students to work on this. Now, what is COALESCE? Now, from the whatever Monique said, or Chiara, or Simon, what came out as the main message is there are two different things that we are looking into. One is energy, and the other one is networks or data or information. Now, we need energy to run our information network, which is the backbone of our digital world. Now, we also are coming up with something called energy networks, right? What is energy networks? It's the network of different renewable sources of energy that are going to replace our carbon-based energy sources. So we are calling them energy networks, microgrids, that are going to power our electrical cars, maybe solar panels for our home. Now, so we are now having two different networks that are in the game. One is the ICT network that will require energy to run, and the energy network that needs information or data to run. Now, COALESCE is about co-optimization of both the networks together. Now, how we can define different sets of tools. It's a very, very technical project, so through different PhD projects, we will find out a set of tools, a set of metrics that is going to be responsible for co-optimization of future energy networks and ICT networks together. Maybe the next slide. Now, it's a 4 years project, however, the consortium is very small. It's just across 4 different countries in Europe: Ireland, Finland, Portugal, and Cyprus. And we also have the, now, while I was building the consortium and writing the proposal, something that hit me is that because Marie Curie networks are training networks, we have this flexibility of reaching out to third world countries, where it's a much more bigger problem of educating the masses to at all give them the message what is sustainability and why we need sustainability, why we need to go there, and how their overpollution, over-trafficking is actually contributing towards the degradation of the total environment. So that's why we reached out to some of the partners in Pakistan, and they are also part of the consortium, though they are not receiving any funding. But what we are trying to do is basically we will go out and train the next generation of scientists, the next generations of lecturers that are there on actually the definition of sustainability, how we all together can make the world sustainable. Yeah. So as I mentioned, there are 2 different networks that are in play. One is the energy network, and the second one is the ICT network that has Open RAN, Edge, Cloud, all the different components that we heard from the previous speakers. Now, the idea is how we can develop a set of tools that are going to co-optimize both the networks at the same time. Yeah. So our objectives were very clear. First of all, to define a set of metrics, tools, and KPIs and KVIs for the energy processes. And the second one would be to define or do the same thing for the telecommunication network, and then validate the solutions across both the networks against different use cases. The first use case that we looked into is basically wireless sensor networks or IoT networks. So we will be, again, deploying different, here the core is the ICT network, not the energy network. Here we will be looking at the energy optimization of the ICT network. While in the second use case, where we have in-building energy asset management, there we will be leveraging data information that we are getting from the ICT network to optimize the energy network. We also have the third use case on energy efficient 5G, 6G RAN, where we will be looking into the concepts of fungibility, like Francesco, I think, yeah. He mentioned about how in 6G we are going to see flexibility of resources, how we can switch between different waveforms, switch between different modulation techniques, right? Now, what we are trying to do here, of course, AI and machine learning and other optimization tools will play a big role in the energy efficiency of 5G, 6G RAN, but we are trying to define a new concept of fungibility. What is fungibility? Fungibility is where, based on the amount of resources that are available in different domains, how we can make the network plastic enough in the RAN level so that we don't really have any black swan effect, or if there is any problem in the network itself. Now, the fourth use case is e-transportation. This one is again depending on the energy network. So we will be looking at the energy network and then how information from the ICT network is going to help in optimization of that network. That's all from my side, I guess.
Thank you very much, and really nice to see that your use cases are quite connected as well to the various other sessions in Sustainable Places. So well done, and I will now invite the project in to come, and it's going to be Maria Pia who is going to present it.
So, Thank you for this opportunity of perform a dissemination about our project. I am Maria Piafanti, I am a professor at the Polytechnic University of Bari in Italy. Next, I would like to introduce this project by considering the object of the European Commission that has the ambitious strategic goal to become for Europe to become the world's first climate neutral continent by 2050. But in this context, in order to accelerate the green and digital transition, in the field of mobility, the European Commission placed a big effort to develop SICAM innovative technologies and services. Next. Then this is in this context that we perform this project that is based on the necessity of develop a transition period where the classical vehicle will travel in the cities with the new vehicle, automated vehicles. So next. And then in this context, in this field, into SICAM is implemented, and it is include 21 partners of 10 countries with 6 living labs. Next. And the objective is to develop, implement, and demonstrate innovative services for connected automated vehicles. And the impact for the society will be the safety, the environmental, in order to reduce transport emissions, and inclusiveness in order to ensure inclusive mobility and good access to all people, in particular VRU people. And the approach is based on 3 main pillars that we will develop in this project. That is in the implementation, integration of enhanced physical, digital, and operational infrastructures. Next. What means physical infrastructure? We would like to develop and update the infrastructure of the cities, considering new dynamic dedicated lanes, intelligent traffic lights, intelligent road signs. Next. Digital infrastructure is one of the main pillar because it starts from the existing traffic management system, and we consider new integrated services that are devoted to the traffic of SICAM vehicles. Next. And finally, but it is very important, the operational infrastructure that is devoted to develop appropriate governance models and business models with the aim of integrate the services in urban planning and urban economics to ensure collaboration between the different stakeholders. And we note that this is very important for the SICAM integration in the cities, in the mobility system. Next. Then we develop these 3 pillars in 6 living labs, 4 lead living labs where the services will be implemented in real time in the real system, and 2 followers living labs where the result obtained by the lead living lab will be applied in simulation campaigns. Next. Now, the sustainability aspect of this project that I know is different from the previous one, but it is very important also in this context, the sustainability of this aspect that are devoted to traffic balancing in order to decrease the traffic and congestion in the cities, freight transport and logistics, because the transportation is devoted not only to people transportation, but also to logistics and freight transportation. And the enabler of vulnerable road users, as I said before. And we apply innovative technologies that are artificial intelligence, machine learning, deep reinforcement learning, digital twin, and very important for this application, this contest, vehicle-to-vehicle algorithm and communication, vehicle to infrastructure communication that no, it is applied by 5G technologies, but also we are implementing also by 6G technologies in the new our new project 6G Twin. Next, and thank you for your attention.
Thank you very much, Maria Pia, and indeed you made the transition with the last presentation.
That was the perfect transition, thank you.
It's going to be 6G Twin.
So I will try to be very quick. Well, as Regis said at the beginning, so I'm also amazed by the number of projects we have today and by the complementarity between them. So this project is probably, yeah, I mean, I would not say it is disconnected from energy efficiency, sustainability, and so on, because these KVIs and KPIs are quite important. We need to consider them. But it's a technology-oriented project, let's say. Next slide, please. So the main objective of this project is really to study the concept of digital twin, right? I mean, if I see all the presentations, you know, in cluster 4, cluster 5, SNSGU projects, whatever, you know, all these projects focusing on IT, ICT, and so on, I see digital twinning quite a number of times. It's more simulation-based approaches or whatever. And so if you take a bit the baseline behind this definition, where does it come from? So what we see in the literature, well, at least in the standards, this all started with the Industry 4.0 sector, so on industrial sites. There, the idea was to use digital twinning as a way to replicate the processes of an industrial site again, to optimize a bit how does it work. So basically to create a kind of sandbox so that you can test, optimize, predict whatever could happen before applying this into the reality. This is the principle of a digital twin. So far, this has been very much popular in the, again, in industrial sites, in the mobility sector. We have saw that through into CCAM, the previous project. But so far in the networking domain, well, we have seen a few documents, we have seen a few publications, we have seen a few products, but it's not so much concrete, in my opinion. So the most concrete document we have found so far is this one, so from ITUT, which is a recommendation about digital twin network. So basically trying to define a bit the requirements and a few KPIs around this universe. Next slide, please. Oh, again, yeah, thanks. So these are a bit the conclusions, right? So this is where we started the discussions, you know, before submitting this project. There is still a long way to fully realize the concept of network digital twin. Indeed, at the moment we are mainly talking about definitions, but which are quite well far from the conventional digital twin literature, let's say. Then there is a need to, well, indeed, to demonstrate its applications in tangible use cases, so to make it concrete, let's say. And then we need to properly integrate it into all these future AI-based architectures that we are talking more and more with the advance of 6G. So this is, I guess, where 6G Twin starts. Next slide. Thank you. So I will not go into too many technical details. I would like to keep time for discussion. But what we are doing mainly in this project is really to use, I mean, to try to explore a bit the concept of digital twinning applied to, well, 5G and 6G architectures. And we believe that thanks to that, we will achieve the following operations: network simulation and planning, so how to anticipate what could happen, for instance, in the future, What happens if you remove a G node B, if you change the distribution of the nodes, of the traffic flows, whatever. So of course this is very much useful when it comes to sustainability and testing, different scenarios where the energy can change. Then network operation and management. So there we are more talking about real-time operations. So how to dynamically interact with, let's say, between the digital copy of the network and the physical network. Then data generation by simulation. Well, it's quite important when it comes to artificial intelligence. We all need data to train our models. So a digital twin could be used for that. AI training and inference. So we could also use a DT for that. And what-if analysis, so what I was citing at the beginning. So we are exploring a bit all these options in the project, trying to make it concrete. Then, of course, it's quite a low TRL project, so we will mainly end up with publication, low TRL prototypes, but still the idea is to contribute to the big picture. Next slide. We have 2 demonstrators in the project. The first one is about teleoperated driving, so connected to, well, mobility. And then we have an energy-saving demonstrator. So we really believe that using this principle of digital twin has the potential to optimize in real time the way energy is shared and used over the network. Next slide. So you can see some faces. At least 3 of these faces are in the room now. So thank you for being here. We have a consortium of 11 partners, 8 member states. We're not going to details, just to have a nice photo shared with you. Next slide. Too many slides. And that's a bit the framework here. So we have been a lot to talk about SNSGU. So you are probably only a few in the room to not really know this framework. But let's say that SNSGU is driving most of the, let's say, of the European effort in related to 5G and 6G networking. So they are organizing regular call for projects. And we are quite glad to discuss any kind of opportunities there. So on our side, we have been funded under a specific stream, which is dedicated to system architecture. And as you saw today, there are quite a number of other topics and directions that could be covered. Security, things more applied, trial sites, whatever. So the framework offered by SNSGU is quite large. And I guess this is it. Thank you.
Thank you very much, Sébastien. That was the last presentation indeed. And so the good news is now we have almost half an hour for discussion, and perhaps we may take some questions from the non-speakers first.
Thank you. The 4 non-speakers. Yeah, so many of us just don't know because we're busy doing what we always do and what we have to look at each day, and it's hard to get through each day. So I didn't intuitively understand how this workshop connected to the conference, and now I do, and it connects perfectly. So thanks for being here, number 1. Number 2, out in the hallway of the Building Digital Twin Association, which has been working through some of these issues now for 3 or 4 years, taking steps in terms of trying to define what is this digital twin for the building sector and trying to work on standardization, because we can't do everything smart buildings until we improve and standardize our ontologies. And it sounds like maybe there could be some lessons learned that would be transferred. They have a conference next year in May at COALESCE University in Lithuania. It's the Building Digital Twin International Conference. And this year was excellent, had so many representatives from university, and it's kind of a sister conference to this one. So I just point that out, and would be happy to do any linkages with Ed Laskos. So congratulations on putting the workshop together.
Any other question? Monique, yeah. Sure.
Well, I don't know how you want to go on with if we stay like this, it's a round table.
I think, yeah. Let's keep it.
I would turn.
Yeah.
Oh, I mean, you could also see there.
No, I feel...
as you like. Really?
I take this and I come down there.
Perfect.
No, but...
And I just keep
I think one very interesting point about digital twins is the rebound effect. Because you say you use digital twins to... somehow, and it's a very strategic tool to simulate and optimize at the end of the day a lot of things, including energy consumption, at the same time to maintain digital twins it's extremely expensive in terms of energy. So have you been looking at these rebound effects and how to compensate on them?
Not yet. But we will, I mean, the project just started. I mean, I'm so happy to have several partners for the project.
Yeah, we do, because one of the things I mentioned is we say we add intelligence into the network to save energy, but by the cost of training these models and the cost of running the inferences, potentially use more energy than you save. So it is something in our scope. That's one aspect we've been looking at and studying, and we've shown that you can save money, but of course you need to take that into account in realistic scenarios. Otherwise, although the researchers are happy, in the end, there will be no commercial adoption of these things if there's not a demonstrable improvement on cost and fulfilling the green goals.
Just to provide an answer. So I guess building a digital twin will require some energy. But at the same time, we would like to use a digital twin to save energy. So I guess this is also something we need to evaluate in this project, in other projects dealing with digital twinning. The compromise between, because indeed whatever we are doing, I mean, this requires collecting quite a lot of data sets, then we need to harmonize them, to transform them, to store them somewhere, to maintain a living, representation of the physical network, so this could be very, very costly. And I guess this is part of the things we have to, study.
No, I was just going to say it depends on how you build the digital twin. Now, one of the major concerns that Sebastian mentioned is about data. Now, gradually we are moving towards building digital twin that are data-free, model-dependent. So we can actually borrow concepts for complex system sciences, computational biology, where so we are running two different SNS projects. One is 6G SNS Ops, and another one is a precursor to it. It's Imagine Beyond 5G. And there we are looking towards building digital twins of networks based on concepts of computational biology. We are using something called agent-based modeling, where the model is derived from concepts of physics and mathematics, and you don't need data to train it. You can start from zero data. However, if you get data along the way, then you can train it even more and make it, or like a reinforcement learning, or sorry, like just learning more and more and getting the model much more refined. But you can start with zero data, and then you can refine the model.
I think, for me, it's clear that there's a lot of alternatives, and I thought that also Francesca.
Sorry, I guess that very much depends on which scenario you are. So if you are in a scenario where data is scarce or it's complicated to make, now we were seeing in the other presentations BMI, so somebody that must input manually, that then in that case probably approaches that do not require any data or can work with a small quantity of data, they can be very interesting. On the other side of the scale, there are scenarios where networks produce data continuously, all the time, and that's too much data. You usually do not need all the data, and then you have the problem of choosing which data you want, which is something that we touched into Centric. So I guess one preliminary step is understanding where you are on the spectrum from very scarce and super expensive data to too much data.
I guess I have some ignorance in terms of how big the problem is. Because it saddens me to hear that we wouldn't progress as a society because we're concerned about using energy to make a digital twin. Well, we make more energy, but in a responsible way. So, is there anyone working on or considering part of this problem in terms of if I need energy to do this, then I employ solar, and if the solar has embodied carbon, I go plant some trees. So, in some circular way, I'm not destroying the world as as I use AI and swarm data to make digital twins to do something useful for society. But I don't know how painful the problem is and how much energy is very painful, huh? So I should stop generating images with AI and not...
More connected to what we were speaking before, but that's the point anyway. We're just started with the question and answers about sustainability in upcoming 6G technologies, and we're already right to the chase of we want to improve the sustainability of the technology. We don't have the technology yet. We're in the phase of designing it. We already know that it will heavily rely on training, for example, digital twins, and with a huge usage of artificial intelligence, which are both known to be very, very power-hungry technologies. So how much do we have, can we save by using these technologies to help us save energy even though they consume themselves? It's going to be really tough. And for example, in 6Green, we're not into the circular aspect. We, for example, recognize the presence of green sources like solar and decide to make deployments in accordance. But again, we need to use these technologies, especially I'm speaking about AI here, not much about digital twins, sparingly and only when and where strictly required, because they consume a lot. And the paradox of consuming a lot of energy to have a perfect algorithm that tells you how to save energy is quite likely. So that's something that needs to be pondered very, very carefully.
Coming back to the point, Thomas, I don't know if we need the mic because no, but because we hear each other. Ah, the online. Sorry. Yes. No, that's true. No, because the poor registe has to... It's okay. No, the point you were making before, it's a huge problem, the one of offsetting the negative versus the positive impact of digital technologies. And it's not only about data, it's about AI, it's about blockchains, it's about a number of technologies that are very promising on the one hand to even address environmental challenges, but on the other hand, they are part of the problem. Now it's about the total CO2 emission worldwide of the ICT sector is exploding, it's growing exponentially. So it's clear that, first of all, it's not just about the use of technologies, it's also about the creation of the infrastructure that are, disrupting ecosystems, the environment, they are polluting. So there's the old part of creating the digital infrastructure, creating devices that are very polluting. I mean, the rare minerals extraction, it's a terrible problem. The disposal of electronic devices and of technologies, it's becoming a huge problem. So it's clear that digital is a key ingredient of the green transition, but it's also a big part of the problem. And it's a chicken and egg situation as of those days, because nobody really knows how to measure the impact of a given technology in terms not only of energy consumption, but also of the other aspects that are, compromising biodiversity, contributing to climate disasters, and you name it. So, and we started very late to work on these as technologists. Technologists are not aware of what it means to build green technologies, especially within the ICT context. And that's why things are now, I think these projects in the SNS are a good example. There are other in other domains, so green data spaces, so there's a lot going on. And I think we need to connect the dots if we want, at the end of the day, to have net zero emission.
Well, then one question, because you are one of the CSA, I mean, you are representing one of the CSA projects funded by under SNSGU. So can you share with us the methodology you have or you would like to adopt to have a common set of KPIs, KVIs, whatever, for all the SNSGU project? Because I think it's also about that, right? you are talking about measurements, so I guess.
I think you touched a very important point. As a CSA, we will not, and a small one, we will not be able to deliver the framework that fits all situations. But what we are trying to do, together with the other SNS projects, together with the Sustainability Task Force, is to identify what kind of criteria and processes must be put in place so that the design, from the very beginning of the technology life cycle, so from the design and conception, those criteria are enforced in different ways. Of course, there's not a framework that will fit them all, but definitely, as I mentioned in my slides, what we are trying to do together with other projects is to define a set of common KVIs, because it's not only about energy, and most of the projects speak and focus on energy, but there's much more, and we're trying to, we have a discussion planned next week with the SNSJU, but also with representatives of the two other CSAs and of the Sustainability Task Force, because we prepared a set of recommendations to be taken into account when writing the work program, so that the projects will also, by design, include work that will allow to create this framework and to align on a common one. And it's gonna take, I think, a few years and a lot of money.
If I may, maybe, on the way to this workshop with Sébastien, we just met with a project officer from the Commission, Sylvain Robert. So he works for CINEA, and more especially this LIFE program. And he saw the 6G tweet, and he said, wow, that's new. And in fact, so yesterday in this same room, there was a full track all day on energy performance certificates of buildings. And what Sylvain told us is, wow, that's interesting what you do, but in fact, the Commission would be interested probably on, not from a research angle, but trying to study really what's the carbon footprint of all this infrastructure indeed, and is there some standards, some indeed methodology to assess that, to make an equivalent?
Yes. Well, the Commission, with my company, were involved in a European initiative called European Green Digital Coalition, which is gathering mostly industrial and private players trying to align on decarbonization methodologies and metrics. So the idea goes from defining common metrics to certifying them. So certification is definitely the ultimate goal, and when you get there, you can have more guarantees. And this goes back to the question that Chiara put on this challenge that you said. I think we cannot leave it at Western style, right? The Wild West. So we will need regulation, we will need certifications, and this must happen as soon as possible. It's like disposing materials for buildings, disposing electronic devices, it takes the same kind of energy.
Thank you. Question at the back.
Hi everyone, I'm Vahid Niksh from Lund University in Sweden. My expertise are not about what you discussed, but I was interested to listen. What we do, our research is very much about energy management at the urban scale, and we definitely praise having access to data, this digital twinning. We were working on that during a period. But now hearing that, okay, this digital twinning itself takes too much energy, then the question is, do we need to move this much towards digital twinning? Should we have digital twin for everything? Or in your projects, what's the focus of having a digital twin? For example, is mobility, energy at the urban scale or not? Because, for example, for energy management and control at the time at the urban scale, we are moving more and more in our project, we are moving more and more towards having agent-based control, not having any cloud computation, both for cheap ICT solutions and data security and user privacy. So what's the trend? Should we move more and more towards having digital twin of everything or not?
I think Sébastien first want to.
Thank you for the question. So Yeah, I don't think the idea is to create a digital twin of everything, right? It would be a nice technical objective probably, but I'm not sure if it would be so much useful. So I do think we need to be problem oriented. So we need to identify specific scenarios that would require some sort of prediction, data generation, whatever. We need to list these scenarios to identify scenarios where it makes sense. You know, today, if I take the case of mobility, there are already so many mobility management systems, so you cannot replace all of them by a super nice digital twin framework. I mean, I'm not sure it would be more efficient, and probably in terms of energy, it would be chaotic, right? But for some specific problems that are not solved today, I mean, I could think about I don't know, traffic light deployment, optimization. I think it's an NPR problem, right? So it's something very complicated to solve if you take just an optimization engine or if you try to use the current solutions that are deployed on the market. But then maybe with a digital twin, you have a kind of loop where you can test different scenarios before applying them into the reality. So I think it should be problem driven, otherwise it does not make sense, yeah.
Connected to what you just said, digital twins probably similar to AI, and so they are tools towards a goal. So if they become the goal, probably we are going off track. Now we create the digital twin of everything, and that becomes wasteful. So maybe it's more productive to start from the decision. So what am I going to decide? So if I am planning a building, probably spending 1 megawatt hour to train my digital twin is worth it. If I'm steering this beam for the next few microseconds, no. So digital twins are a tool, and whether we do that or not probably depends on the goal.
In your response to this, this idea of using agents that are embedded rather than central cloud, that's something that is coming back in many architectures towards 6G as well. So there's a realization there's so much telemetry, you can't just ship it northbound into the cloud and do everything there. Rather more this sort of federated learning, distributed federated learning, including for network digital twins, is certainly a big trend that is happening in the 6G architecture. Not in necessarily the projects here, but in other complementary projects. That is happening in 6G architectural design as well.
I wanted to say that for me, digital twins, it's one option. It's not the option. You have very different ways of simulating situations for optimization purposes. You have multi-agents approach that date back also like, I did a PhD on multi-agent systems for optimizing traffic in networks, in communication networks. And the amount of data that you need to perform decisions, it's very much depending on the kind of decision and the scope your agent is moving within, because typically you need some data. But what I wanted to mention here is the fact that edge computing and the fact that not everything is going to be in the cloud is one of the important trends that we have to consider that is happening at the middleware level. In fact, the Commission already announced in February these 3C visions. It's collaborative computing continuum networks, right? And the core there is that you need to ensure that many of the decisions will be taken at the edge. So you don't centralize data, you put intelligence more to the edge of the network or at the edge of wherever the decision, and agents will be there with different levels of autonomy. So I think that the whole ICT is moving towards this, vision of having a more decentralized computing and decision-making infrastructure.
The concept of edge cloud continuum is very relevant to, it was already very relevant to some extent to 5G technologies, because already thinking just about the structure of the 5G core, where you've got a number of virtualized network functions that perform very specific tasks. Some of them need to be closer to the user, especially the user plane function, because you need to be very reactive. You need to, the user moves, you need to activate a network function that is close to it. Some other functions more related to the control plane, to operations that are not heavily dependent on the traffic, can be performed remotely, can be performed in a separate data center. So we already had this going on for 5G technologies. This is becoming even more relevant for 6G as we move to an Internet of everything. So proximity is going to become a key concept, but we really need to have this heavily considered also from the sustainability point of view, because it can be a drawback, of course. You need to have a lot of servers that are active, that are running fast, close to the application and so on. But on the other hand, this can be also a valid tool, for example, to have the deployment closer to a green source of energy. Or you can, on the other hand, instead of thinking about you're activating some resources close to an application, to a user, whatever, you can also think about you can switch off those when they're not needed. You can centralize and decentralize, so it's customizable. It's getting more and more customizable. This can be a very powerful tool if we use it the right way, in my opinion.
Thank you very much. If I may, I would have a question as well for Simon. In your presentation, you mentioned those private networks in some specific applications, and so this morning we had a session by the Smart Building Alliance Luxembourg. So they discuss everything, smart buildings, sensors and all that. But it's true that so far, well, the 6G or mobile networks are not so much discussed. So do you think that's because it's not relevant, or perhaps it's a use case to further explore?
I think it's something that's starting to evolve, all these private networks. I mean, often it was constrained by the availability of spectrum, having frequencies to transmit on that were all licensed and very expensive. But that model now in certain countries like Germany, and it was one of the drivers in Europe and the US and the UK to some extent, the sort of availability of local licenses for campuses or sharing of spectrum, those things are starting to enable a new thing of more affordable private networks. So yeah, it's like I said, initially it's more the rich verticals like manufacturing that adopt private networks first, but the sort of being able to install a private network during a construction site or a refurbishing site of buildings and connecting all the drones and robots and using sort of AV vision and goggles and things to see what's going on, but in a reliable way. I think those verticals is certainly an area that it's a growing area, and it's still very undeveloped at the moment, but it's something that will significantly grow. But utilizing the same technologies, I mean, as everything goes to software and being able to run a small-scale version for a private network but be fully compatible with the big networks is one of the drivers for this. So, but in the end, it will come to economics, availability of spectrum and cost, and who runs them, who installs them, because they can be difficult to operate, so they have to be automated to simplify using them where you don't have specialists that you do in telcos and things to run them.
All right. Yeah, Monique.
I think we should write a proposal together. No, but really.
Excellent transition.
Maybe off the records. No, we should write a proposal together. Yeah, it would be nice to write at least out of this session a position paper, because I think connecting the dots and maybe propose some, in the SNS context, something more related to smart buildings could be a very good idea. And vice versa, bring a little bit of the
key sustainability indicators that you mentioned.
Yeah.
Those are going to be already integrated in the next SNSGD calls? Or
in the next call, there will be KVIs for sure, and hopefully a little bit more universally accepted within the SNSJU, so understood. And because the questionnaire there was a questionnaire that was run with 60 plus projects, and the answers showed that clearly people do not understand what it means, sustainability within the context of, not yet. We're not yet there, right? So there's a lot of potential, and that's the good news. There's a lot of potential, and this is what we should be working on. So I think in the World Program 2025, I'm not sure there will be specific mentions to KSI, so key sustainability indicators. No, I'm not sure.
Yeah, just to mention. So I fully agree. I mean, first, so I think this was the plan, Regis, to write a kind of position paper where we highlight the conclusions. I don't know if we have any kind of conclusions from this the discussion, but at least work on a paper where we would identify, I don't know, the known problems, issues, or whatever. I mean, that could be useful.
So that's what we propose to every workshop on sustainable choices. We have this partnership with Open Research Europe, and we can publish many different formats. One of them is an open letter, it's very short.
2-4 pages.
More like a policy statement, or we agree on a challenge and we co-sign this.
And then I would say it's perfect. I mean, we are what, 8 projects, 8 partners, 8 with several entities behind. So I mean, if you are open, well, I guess we have until April.
Well, thank you very much. I think we can probably conclude with that. Perhaps maybe as well as on the next steps, Sébastien, you submitted a proposal for the Mobile World Congress, right? And last Friday. So perhaps there is room.
Well, the acceptance rate
is very low. Voilà. So let's wait for the feedback of that. But voilà, perhaps there is room to reproduce such a workshop in a conference, which of course is there. Very much focused on that, but sustainability may be something new that we propose. I guess that Sébastien is going to keep you updated on whether we are accepted or not, and then indeed we can get back to you regarding this open letter. We could write together so we can start a draft, okay, and then we share with you. And there is a deadline. There is. But the deadline is very flexible. We are very flexible in general. So let's say that we should target before the end of the year or something like that. Okay. Formally speaking, it's normally end of October, but voilà.
I would suggest so independently on this open letter or whatever. So when the new work program is known, then let's just organize a meeting and we discuss if we can identify synergies, whatever. We'll see. So I guess around November, probably. Yeah. Thank you.
I'd like for the speakers and well, for any other who is interested as well, I'd like to suggest a photo, a group photo at the photo booths you may have seen in the corridor. And one there. Yeah. Let's do one here first, and then another one at the photo booth. Thank you very much.